And next topic is minimization of finite automata. So minimization of finite automata is nothing but for a given finite automata, now we have to reduce the states, and that reduced finite automata will give you the same result of the given finite automata. So for minimizing a finite automata, we have two methods. So the first one is a general method, so which is also known as an equivalence method. So in this, we are going through the following steps for minimizing the given finite automata. So these are the steps we can follow. In step 1, so first of all, we have to create a pi naught state. So this pi naught will consisting two states. So one is a set of states, so which will consisting all your final states, and another set will consisting all your non-final states. So now you can group the given set of states to two different states, right? You can divide it into two different states. So one set will consisting all the final states and another set will consisting all non-final states. Right? Another set will consisting all non-final states. So now this final and non-final states, if you are getting more than one state in that particular group, so now you are going to make a comparison. Means you are taking that states and you are finding the transitions with the possible inputs given in your transition diagram. So for that you have to identify whether that states is belongs to same set or not. If it is belongs to same set, you can keep as a same group, or else you can split into different groups. So you can do the same step again and again until you are not finding any division part. So that is of your step 2. And in step 3, so you can construct up to pi n for n equals to 1, 2, 3 and so on until pi n equals to n plus 1. That is the previous state and the current state is both are same, then you can stop. And then replace all the equivalent states in one equivalence class by representative states. So this is an algorithm in general way or in equivalence method how you are going to construct a minimized finite automata for a given finite state machine. So I will show you both methods. So this is the first method. So we are going to discuss the first method, that is your general method or equivalence method. So this is a transition diagram given for you. So remember, first of all, when a transition diagram is given or a state diagram is given, so you have to convert into a transition table. So you all know how to convert transition diagram into transition table. So you just convert it, like you can take all your states, so and take all possible inputs. So here I have two possible inputs A and B, so that I can take two possible inputs A, B here. And from that, so I can write the states like Q0 with A. You can see Q0 with A. I'm going to move Q1 state. With Q0 with B, I'm going to take the same state. So you can write like that for all the states. And from this transition table, you can identify which is an initial state and which one is a final state, but by this representation. So you can give an arrow. So it is indicates that it is a initial state, and you can give a circle that indicates the final state. So now what your first step will say, you can divide your set of states to two sets. So the first set will consisting of final state and the second set will consisting all your non-final states. So now see here, you can start representation of pi suffix 0. So you start with the beginning is a pi suffix 0. So which will consisting of two states Q1 and Q2. See here Q1 state and Q2 state at 0 level. So at the initial level, so now the first set will consisting only the final state and the second set will consisting all the remaining non-final states. So this is your pi naught. So pi naught will consisting of Q1 0 and Q2 0 because I have only two states. And now Q1 0 means at 0th level, I have only one final state. I need not to compare that state. I just leave it. For Q2, I'm having more than one state. So I'll start comparison with Q0 with Q1, Q0 with Q2, and Q0 with Q4, Q0 with Q5, Q6, and Q7. And I'll find out that all these states again together into a single group, or else it can be splitted into a different groups. So I will show you how to decide whether they are included in a same group or it will be divided into a different groups, right, a little bit later. So now you compare Q0 with Q1 with all possible inputs. So you compare Q0 with Q1. So Q0 A we are going to Q1 and Q0 B we are going to Q0. So at the same time Q1 with A you are going to Q0 and Q1 with B you are going to Q2. So now we are finding the combinations here. Q0, Q1 you are getting a combination and you can find the both are available in same set or not. Yes, Q0, Q1 both are available in same set. And then Q0, Q2 is also available in the same set. So for the next level, I'm constructing Q, right? So this Q0 and Q1 is grouped together, right? I cannot separate from the group. So I can include Q0, Q1. The same thing I can continue for Q0, Q2, right? For Q0, Q2. So with possible inputs A and B, I'm getting Q1, Q3 and Q0, Q1. So now you consider this state Q0, Q1 is belongs to same state, but Q0, Q3 will be two different states. So here I'm finding in column A, I'm finding my Q0 and Q2 will be deferred, right? Means of that if I'm taken A as an input, so I cannot reach the same states. Means I cannot be an intermediate states or I cannot be a final state. So one time I'll be in intermediate and one time it will be in a final state, so that these two states are not included as a same group. And you have to decide which comes under the groups, and you consider these inputs also. By taking the same input, we are getting what are the different things, and we can make those things as to defer and we put it as a state. So now remember Q0 is deferred to Q2 at column A, and for Q0, Q2 is not one equivalent because we cannot put as a single group. For finding Q0, Q4, I am getting Q1, Q3 both are not in same set, and Q0, Q5 is having in same set. So now here also I am finding at column A, I am finding Q0, Q4 is also not in same group. So I'm compared with Q0 with Q5, I'm getting Q1, Q6 in a same set, and Q0, Q4 is also in a same set. So it will be included with Q0 in a next level. So it will be grouped with Q0 in a next level. And then Q0 with Q6, I am finding Q1, Q5 will be in a same set, and then Q0, Q6 will also be in a same set. So now We are including this Q6 also with Q0 in a next level. And then next Q0 with Q7. So I'm comparing Q0 Q6 I'm getting and Q0 Q3 I'm getting. So Q0 Q6 will be the same set, but Q0 Q3, these are in two different sets because Q0 will be in a non-final set and Q3 will be in a final set. So now you can observe here this Q0 is deferred to Q7 at column B, right? So now you are finding two states is deferred in column A and one state is deferred in column B. So now because of that reason I am getting different states at this level. Q1 which is a final state which I am including from my 0th level, and from that and after that I am getting the states. See here, so some of the state we are included with the Q0. What is the states? Q1, and then here it is Q5 and it is Q6. So now you can include those with along with Q0. So Q0, Q1, Q5 and Q6. And after that, for the next, I am grouping Q2 and Q4 because Q2, Q4 will be deferred in a same column A. So because of that reason, I am making this Q2 and Q4 will be in a same group. And after that I am getting Q7 is different in column 7. So I don't have any other combination with the same difference. So I can include as a single state. So now this is at Q1. So this is at first level. So these are the states I am getting at first level. So now you have to find the second level by using the output getting from the Q1. So for comparison, means here we have only one state we need not to compare, and here we have 4 we have to compare, and here we have 2 we have to compare. So how we are going to compare Q0 with Q1 and Q0 with Q5 and Q0 with Q6. So the same way, see here Q0 with Q1 and Q0 with Q5 and Q0 with Q6, and so these are 3 comparisons is required for this set and 1 comparison is required for this set like Q2 and Q4. So now we are comparing Q2, Q4. So here, so we can find both are in lies in same set. See Q3, Q3. So will be in a same set like Q3. So here it is. And the second one is we are getting Q1, Q5. So Q1, Q5 is also from the same set. So now at the next level also, this Q2 and Q4 will be grouped together. And here we are finding Q0, Q6 are equivalent. And here we are finding at B column, Q0 is deferred with Q5. Q0 with deferred with Q5. So you have to separate it. And here also you are finding Q0 and Q1. It is also deferred at state B. So now you can combine this Q1 and Q5 for the next level as a group. See here, because of that reason, Q0 and Q6 is included and Q1, Q5 is as grouped together and Q2, Q4 are included and Q7 and Q3 from the previous state it is going to be included. So now it is at level 2. So you can continue until you're finding the next level is also similar to a previous level. Means the current level is similar to a previous level. As of now, you have to continue the same procedure. So now I can have two different states like Q0 is going to compare with Q6, Q1, Q5 is compared and Q2, Q4 is compared. So here we'll do that. Like Q0, Q6 is compared. So you can see Q0, Q6, Q1, Q5 and Q0, Q6. So now you're finding Q1, Q5 is also in same state and Q0, Q6 is also in same state. So Q0, Q6 will be into the same group itself. And you compare Q1 and Q5. So now you're finding Q1 and Q5 is compared. So compare Q1 and Q5. Q1, Q5 with possible inputs A and B. So what you are getting? See, with possible inputs A and B, Q1, Q5. So Q1 is Q0, Q2 and Q5 is Q6, Q4. It is Q0, Q2 and this is Q6, Q4. So now you are finding these two will be in same set Q0, Q6 and these two will be in same set Q2, Q4. So now in a next level also Q1, Q5 will be in a same set. And you compare Q2, Q4. See here Q2, Q4, one time you are getting Q3 will be in a same set. And then for Q1, Q5 will be in a same set. So now you are finding Q3 equals to Q2. So Q3 is a current level and your previous level is Q2, pi 2. So this both are equal. So because of this reason, we stop construction of this sets, right? We stop construction of these sets and you can group all these similar states. Like we have how many states? This is one state and this combinedly Q0, Q6 will form the second state and Q1, Q5 will form the third state and Q2, Q4 will form the fourth state and then Q7 will form the fifth state. So initially we have how many states? Totally 8 states we have. For a given question, you have 8 states. And now after reducing, you are getting only 5 states. So now this 5 states machine will be an equivalence to your finite state machine. Right? So now you can rewrite your transitions like Q0, Q6, Q1, Q5, Q2, Q4, Q3 and Q7. Right? So you can rename or else you can use as usual. Right? See here. So at Q0, Q6. Now you are finding Q0, Q6. You are getting combination as Q1, Q5. For Q0, Q6 with B, you are getting Q0, Q6. Because see here Q0, Q6, Q1, Q5 both are same. Right? So you can write the transitions like this. Right? So now for the same transition table, you're going to draw a transition diagram. So here which state including Q0 will be an initial state and you know Q3 will be a final state given in your final state machine itself. So now you can make Q3 as a final state. So this is an equivalent DFA for a given or the equivalent minimized DFA for a given DFA. So now we don't think like for every problem we are getting a minimized finite automata. Sometimes we can follow the same procedure. We cannot reduce the finite automata. That means of that the given finite automata itself is a reduced finite automata. Okay, so this is a minimization of finite automata. So by using a general method,